And welcome once again to our discussion in Earth Science Grade 11, Quarter 2, Lessons 9 and 10. This is once again your teacher, Miss M. Magdadaro from Tagaytay City National High School. Today's discussion is focused on this milk to describe how layers of stratified rocks are formed. The following objectives are to be attained in our discussion today for this lesson. First is to define stratification and describe the process and how stratified rocks are formed. Now let us review from our past discussion. In our previous discussion, we discussed about the structure and the evolution of the ocean basins. Now when we talked about the structures, these involve the following parts or structures. We have the abyssal plain, the mid-oceanic ridge, the guyot, the trench, the seamount, continental shelf. We have the continental slope, the continental rise, and the transform fault. And of course, in our previous discussion, we also dealt with the different basic types of plate boundaries. You can see in the picture, we have the divergent boundary, the convergent boundary, and the transform boundary. And we use these hands gestures to show the relative motion of these types of boundaries, which are easily to be remembered because of this. Now let us consider some of the terms that we will be encountering during our discussion. So let us have first what bedding is. Bedding is also called stratification. This describes the sedimentary rocks layering and sometimes the layer found in metamorphic rocks. Next up is the sedimentary rock. This is a type of rock formed by the accumulation of sediments with subsequent cementation of minerals or organic particles on ocean floor or other bodies of water at the Earth's surface. And we also have the strata. This is also referring to rock layers, which means that a rock strata is composed of preserved and fossilized species, and this comes an understanding that will help the scientists to piece together the evolutionary history of a group of organisms and Earth's history as a whole. Then we have the stratigraphic laws. These are the basic principles used and applied by geologists to determine the age and characteristics of rock layers. And of course, we have the stratigraphy. Stratigraphy refers to the study of rock strata or layers. Let us talk about how rocks are arranged in layers. This process is known stratification. When you go for a hiking or a mountain climbing, you see visible layers of rocks everywhere. These layers are arranged naturally in the environment. The horizontal layers present in most sedimentary rocks are called strata. The process of creating layers of rocks is called stratification. This is not only happening in sedimentary rocks, but also in igneous rocks. Now, rocks that are hardened over time create layers that make it a stratified rock. There are steps to consider on how stratified rocks are formed. The first one is the weathering. The second is erosion. The third is deposition. And the fourth is compaction. Talking about weathering. Weathering happens when large pieces of sedimentary rocks are broken down into smaller pieces, and these pieces of rocks come together with other materials to form sediments. Now, while these sediments that are lightweight are being transported over time, This is now being called as erosion. And here comes the next, in which what we call deposition. It is when the sediments together with fossils will settle in a certain place after being eroded. And the last part is what we call compaction. This is when the deposited sediments will begin to stick to one another, cemented together with clay and other minerals and fossils, and compacted, creating a layer of sedimentary rocks. Over time, another layer of sediments composed of other kinds of materials will pile up on top of this first layer, forming a stratified sedimentary rock. Now, this stratification process happens hundreds of years or more. A Danish scientist in the name of Nicholas Steno studied the relative positions of sedimentary rocks. Steno made mention that solid particles settle according to the relative weight and size. First, the settle is the largest and heaviest one, while the smallest and lightest are the last to deposit. He said that layering is the most evident feature of sedimentary rocks, and the particle size and composition of the materials contributed much to the layering of rocks. Who among you ask among yourselves, how do you think these geologists study about stratigraphy? Now, in their study about stratigraphy, they consider some of the fundamental principles of it, and we are going to discuss them one by one. The first one is the principle of uniformitarianism. This idea or principle was postulated by James Hutton from the year 1726 to 1797. This is when he examined rocks in Scotland and noted that features like mud cracks, the ripple marks, or the graded bedding and so on in rocks are the same features that could be seen forming in modern environments, and that past geologic events can be explained by phenomena and forces observable today. So Hutton concluded that processes are currently operating on the Earth must be the same process that operated in the past. And later, he stated that the present is the key to discover the past. Second is the principle of lateral horizontality. This idea was proposed by Nicholas Steno from the 1638 to 1686. This is when the sedimentary strata that are deposited in layers are horizontally or nearly horizontally formed parallel to the Earth's surface. Sediments deposited on steep slopes will be washed away, as if they deposited in nearly horizontal layers that can be buried and litified. These rocks that we often see that are now inclined or folded, according to him, have been disturbed after their deposition. Nicholas Steno also proposed about the principle of superposition, in which, as you can see in the picture as an illustration, the rocks or the layers of rocks are arranged from the oldest to the youngest. Like from the bottom, we see that the oldest layer is found at the bottom, and the youngest layer, which is newly accumulated, is found at the top of it. So this law states that in a sequence of sedimentary layers, each layer must be younger than one below and older than ones above it. Because of Earth's gravity, deposition of sediments will occur, depositing older layers first, followed by the successively younger layers. There are some instances that this sequence of layers will be overturned because of some later deformational events. And also there is what we call principle of cross-cutting relations. This was first developed by Nicholas Steno, but later formulated by James Hutton and embellished upon by Charles Lyell in 1830. So this principle states that if one geologic feature cuts across another, the feature that has been cut is older, and the younger features are truncate or cut across older features. So for example, if there is a sequence of sedimentary rocks that cut by the basalt dike, we know that these layers had to be present before the intrusion of the dike. So the dike now is younger than them. So similarly, fault cuts the same sequence but does not cut the basalt. Thus, we know that the fault is younger than the sediments but older than the dike. Next up is the principle of inclusions. If we found a rock fragment enclosed within another rock, just like as you see in the picture, we say that the fragment is what we call inclusion. And we know that this inclusion had to be present before they could be included in the younger rock or the rock that is enclosed by it. So they always represent the fragments for an older rock. So this, what we call inclusion, represents the older rock, while the one that is enclosing it is representing the younger rock. So if the enclosing rock is an igneous rock, the inclusions are called xenoliths. And this principle is often useful for distinguishing between a lava flow and a sill. And the principle of chilled margins. So like when a hot magma intrudes into a cold country rock, the magma along with the margin of the intrusion will cool more rapidly than the interior. So fine-grained rocks or glassy rocks will be along the margin, whereas coarser grain will occur farther away from the margin, just like you see in the picture. So chilled margins are younger than the surrounding rocks because the surrounding rock had to have been there first in order to cause the cooling effect. So when the magma comes in contact with soil or rock or soft rock, heating up results in a big zone in the surrounding rock near the contacts with the igneous body. And the principle of correlation states that the rock units may be correlated within a region, a continent, and even between continents. So this is used in determining time equivalency of rock units. So this is based on matching physical features such as the rock unit, similar rock types like the marker beds, the coal seams, the rare minerals, their odd, or the color. Fossils represents living creatures that have evolved through time. So when we found a fossil of the same type in two different areas or sections that are laterally continuous, we are pretty sure that the rocks are about the same age. So this is the principle of correlation. These correlating beds using the index fossil. So basically, why do we have to know about this principle of stratigraphy? What is the significance of this? Now, principles of stratigraphy are the geological tools that helps in determining the relative age and the numbers of existing events and even the field relations that can be estimated from one outcropped or from different. Now in lesson 10, which is the relative dating and absolute dating, we are focusing on MELC 10, which is to describe the different methods, the relative and absolute dating of determining the age of the stratified rock. And we are going to inline our discussion with the following objectives. First is to describe how layers of rocks are formed. Second, to describe the different methods, which is the relative and absolute dating, to determine the age of stratified rocks. And of course, explain how relative and absolute dating were used to determine the subdivisions of geologic time. In relative rock dating, we determine the comparative or the relative age of the rock to each other. However, this technique cannot give the exact age of the rock. This is only used to arrange geological events based on a rock strata or layers. So relative rock dating is guided by the three basic laws, which is known as the Steno's laws, authored by Nicolas Steno. And these laws are the basis in determining the relative ages of rock layers or features. The law of superposition states that the older stratum lies below the younger layer, while the law of cross-cutting states that any feature such as the fault that cuts across a sequence of rock is younger than everything it cuts. And of course, the law of inclusion states that any rock or fragment or intrusion that is included inside or another rock is older than the rock in which it is included, because that rock was there already before it was being enclosed by any type of rock. So these are the basic laws that are included in the relative dating. And of course, aside from the relative dating, we also have the absolute rock dating, or the other way around, we call it the radiometric dating. This is a kind of technique that is used to determine the absolute age of rock. Thus, in this technique, the decay rate of radioactive isotopes which are embedded in the rocks are measured. So what are these, what we call isotopes? These are the elements with equal number of protons but different masses. And these are some types of absolute dating that we have to know about. The first one is the carbon dating. Now, carbon-14 dating is a good technique in determining the absolute age of fossils found in rocks. So fossils, as we know, are remains of organisms preserved in rocks. For example, a tree, which is a living thing, takes in carbon-14 and carbon-12 at the same time. So when this tree dies, the carbon-14 starts to decay and becomes less, while the carbon-12 is unchanged. So then, the ratio of carbon-14 left to the unchanged carbon-12 is being measured. So with this, the absolute age of the fossil is determined. Now, carbon-14 has an equivalent half-life of 5,730 years, meaning every 5,730 years, the parent isotope will produce two daughter isotopes, and these daughter isotopes will produce another daughter isotopes, and so on and on. And another type of absolute dating is the potassium dating. This is another example of a radioactive isotope used in absolute rock dating, which is what we call the potassium-40. Potassium-40 has a half-life of 1.25 raised to the power of 10 years when it undergoes a beta decay. And the last, which is uranium dating. This is the oldest known crystal on Earth, which is called as the zircon crystal from Australia. So it remained intact for an incredible 4.4 billion years, which is of almost same age of the planet Earth. Now, the radioactive isotope used to determine the absolute age of zircon crystal was uranium, which decayed also into lead atoms. Now, let us remember that younger rocks can be dated using carbon-14, and igneous rocks contain the radioactive isotopes, which make them good for radiometric dating. So in sedimentary and metamorphic rocks, scientists will look for the presence of igneous rocks embedded in them to determine their absolute ages. It's so amazing to know how rocks become the key to know about our Earth's history. So let us appreciate the value of these rocks in our lives, because it always points us to our past. That ends our discussion today. Thank you for being with me during our discussion. So I'll be releasing our next video in the year 2022, next year, in the first week of January. I know you're very excited to spend your Christmas vacation, so good luck everyone, and have a great vacation ahead of you. And I'll see you next year in our next learning video. See you all!